Matrix multiplication is a little more involved than the scalar multiplication or matrix addition and subtraction. Um, Two matrices, in order to be able to multiply them together, they have to be compatible for multiplication. And what that means is if A is m by n and B is n by p, then you can multiply them together and get an m by p matrix. Now the way I always write this is if you've got A and it's m by n, and you multiply it by b, which is n by p, in order for you to be able to multiply them together, these have to be the same. And when you multiply them out, you get the matrix AB, and its size is m by p. So this and this give you the size of the product. Now, this is the definition of matrix multiplication from the book right here, and it looks kind of ugly the way it's written out like this. But what this is saying is, for each row of the first matrix and each column of the second matrix, you multiply the entries together and add them up. This is much easier to see in an example. So let's look at this. 401. We've got the matrix 2, 3, 1, 407. Now this is 2 rows and 3 columns. So this is a 2 by 3. And this matrix here, 1, 3, 1, negative 1, 0, 1, that has 2 rows, or no, it has 3 rows and 2 columns. So these match up, so we're good. And our answer is going to be a 2 by 2. And here's how you do it. You take the top row of this, and you do, this is called the dot product, which we'll define later on. But the dot product, what you do is you multiply the 2 times the 1, and then the 3 times the 1, and then the 1 times the 0, and you add them up. So that gives us the top entry for this, or the first entry. The next entry we'd get by taking the 2, 3, 1 and multiplying it by this column. So we get 2 times 3 plus 3 times negative 1 plus 1 times 1. And then we do the same thing, but we would use the bottom row. So that times this is going to give us this entry. So 4 times 1 plus 0 times 1 plus 7 times 0. And the last entry is this times this. So it's going to be 4 times 3 plus 0 times negative 1 plus 7 times 1. So now if we just do all this arithmetic, let's see, what do we get here? The first entry is 2 plus 3. The second entry is 6 minus 3 plus 1. So that's 6, 3, 4. Then this next one's easy because of the zeros. We get a 4. And then the last entry is, let's see, 12 plus 7 is 19. All right, so that's our product. Let's look at the next example. This next example, notice it's the same 2 matrices that we had before, but this time they're multiplied in the opposite order. This one is a, let's see, this one is 3 rows by 2 columns. And remember, it's always a row column. Whenever you're doing indexing or talking about size, it's always rows, columns. So if that's a 3 by 2, this one is 2 rows by 3 columns. So they do match up here, and our answer is going to be a 3 by 3. So we'll do this. We'll do 1, 3 times each of these. So we get 1 times 2 plus 3 times 4. Then we get 1 times 3 plus 3 times 0. And then 1 times 1 plus 3 times 7. Then we'll do the next row times each of those columns. So we get 1 times 2 minus 1 times 4. Then we get 1 times 3 minus 1 times 0. Then 1 times 1 minus 1 times 7. And then we do the last row. Dot that with this, we'll get 0 times 2 plus 4 times 1. Or I should say 1 times 4. Not that it really matters, but I'm trying to be consistent. Then we'll get 0 times 3 plus 1 times 0. And then we'll get 0 times 1 plus 1 times 7. And I've used up most of my room here. Let me move this over a bit. And then just go through and do the arithmetic to come up with the final answer. This up here is going to be 12 plus 2 is 14. Oops. 14. This is going to be 3 plus, no, just 3. And then this is going to be 22. Next up, we've got 2 minus 4, 1 times 3. And then 7, or 1 minus 7 is negative 6. 4, then 0, then 7. All right, so I've got that kind of crammed in on the side there, but that's the product. And one thing to notice about this, matrix multiplication is not commutative. So what that means is if you have two matrices and you multiply them together, AB, and then you swap them to BA, they're not necessarily equal. A lot of the time, you can't even do it. You can't even multiply them both ways. And there are cases where they will be equal, but it happens kind of by coincidence. So you can't count on AB and BA being equal. It's not commutative. All right, we'll do some more examples in the next video.